today we're going to be talking about balancing redox reactions, and we're going to be using the half reaction method. So this is the example that's from the lecture slide, so I'll go through it now for you on the lightboard. Okay, so first of all you want to work out the oxidation number on each of these metals in the reaction. So remember, if there's an element and it's by itself and it has a charge, the oxidation number is that charge. So for example, the iron here would be +2. So with the manganese, we've got a compound now, and we know that each oxygen is -2, and we have 4 of them, so to be -8 in total for the negative charges. Overall, this complex has a negative, so we need to make sure there's a negative left over for that one. So we have essentially -7 that we have to cancel out. So the manganese would be +7. Okay, with our other ion, the iron, we've got +3, so to be +3 on that one there, and the manganese is +2. So now what you want to do is look at how they're changing from one side to the other. So if you look at the iron here, we're going from +2 to +3. So what's happening to our electrons? So if you need to, you can write your little oil rig in the corner there. So remember, oxidation is loss, reduction is gain. So looking here, we've got a +2 to a +3. So we're, what's happening to our charge there? We're losing 1 electron, okay? So we're becoming more positive because we're losing an electron. And remember, oxidation is loss, so this would be an oxidation reaction. So if we look at our manganese now, we're going from +7 to +2. So we're actually losing positive charge, so we're gaining negative charge. And we're gaining 5 electrons there. And we've got reduction is gain. So this is a reduction reaction. Okay, so now in terms of which is the oxidizing and reducing agent, remember, if it itself is being oxidized, it's a reducing agent because it's making the other thing become reduced. So the oxidizing part would be the reducing agent. Okay, and the reducing part would be the oxidizing agent. Okay, so that's what we've got to start with. So now we actually need to go through and balance this one. So I always like to start with the oxidation first, but this is a personal preference. It doesn't affect the overall result. So if I look at my oxidation, I've got my iron there. So I've got my Fe2+. I'm going to leave a bit of a gap there, and I'm going to go to Fe3+. Okay, so what are the rules? So the rules... Okay, so first of all, you balance the atom of interest. Okay, so second, you balance your oxygen, and we use that by adding water. Okay, so 3, we balance my hydrogens. We do that with H+. And lastly, we balance our charge. And we go to the more positive side and we add electrons to it. Okay, so starting with the first one, balance our atoms. So we've got 1 on each side, 1 Fe on each side, so they're good. We have no oxygens, we have no hydrogens, so we can go straight to the 4th step where we balance our charge. So you go to the more positive side, which is our +3, and we add 1 electron to bring that down to +2 overall for that side. So remember, 3 plus -1 will give you +2. So it'll be the same on this side. So now that one's balanced, we can look at the reduction half reaction. Okay, so we've got MnO4 AQ, and we've got Mn2 AQ. Okay, probably should have left more of a gap there, but we'll work with it. So we've got MnO4- and we've got Mn2+. So looking at our list, so firstly, we want to balance our manganese, so making sure you've got 1 on each side, which we currently do. The next one is your oxygens. Okay, so number 2 is our oxygens. We've got 4 oxygens here on the left-hand side. So we're going to need to make sure that there's 4 on the other side too. So we can do that by adding 4 waters, because remember, each water brings in 1 oxygen. So now we have the right amount of oxygens on either side. The next step is the hydrogens. So we've got 4 times 2, so 8 hydrogens here. So I need to add 8 here. So 8H plus there. So now checking my charges there, I've got 8 plus, and then I've got 1 minus. So hang on, that's not a great way of representing that. Oh, I just smudged it. Okay, so plus 8 minus 1 equals plus 7 overall for the left-hand side. And on this side here, I've got the plus 2. So I go to the more positive side and I add my electrons. So in this case, this is plus 7. If I add 5 electrons, that will bring me down to plus 2. Okay, so I add my 5 electrons there. So now what I want to do is put my 2 half reactions together. So if I look here, I've got 1 electron. Here I've got 5 electrons. So I need to make sure the number of electrons being transferred is the same. So that way I do not have free electrons floating around. So if I multiply the first one by 5, then I'll have 5 electrons in the oxidation and 5 electrons in the reduction. So I'll rewrite the oxidation out again. So I've got 5 Fe2 plus going to 5 Fe3 plus 5 electrons. Okay, so now what we can do is put the reactions together, now that my electron numbers are the same. So you can cancel things out at this point, so I'll put a line through that one so we don't get confused. So we've got our redox and our oxidation. So finding our electrons, there's one on the left, one on the right, they cancel out. And everything else looks like it would stay the same. So if we had H pluses on both sides, we could cancel that down, or H2Os. But in this case, we don't. So it's just a matter of writing it out again. Okay, so 8H plus MnO4 minus plus 5 Fe2 plus 5 Fe3 plus Mn2 plus plus 4 waters. Okay, so I'll just cross-check that I've done that right. Okay, so that looks good. So in the final step, you have to put in the states. So we were given the states in the top part, so we have to keep them in. So remember, H plus is aqueous. These ones were aqueous at the beginning. And water in these questions are in the liquid state. Okay, so we keep it in the liquid state there. So the only extra step that you would have is if this is under basic conditions. So if this is under basic conditions, you find your H plus and you add the same amount of OH minus to cancel that out. So I'll do that in a different colour. Okay, so it's not a majorly different colour. But okay, so here, H plus OH minus makes water. So that equals 8H2O liquid. And whatever I do to one side, I need to do to the other side. So I need to add 8OH minus to the other side. Okay, so now we're just going to put this all together, and I'll write it back up the top here. So I've got 8H2O, and that's in the liquid form. Okay, so my H plus and my OH minus had made H2O. And then I have my MnO4 minus, my 5 Fe2 plus, going to 5 Fe3 plus Mn2 plus 4 H2O. Okay, and then I'll write my 8 OH minus down there. So then I can go through and cancel out my water. So I've got 8 here and 4 there. So this can cancel down to 4. So that would be, the final answer would be 4H2O liquid plus MnO4 minus aqueous, 5 Fe2 plus aqueous, And again, hydroxide ions are aqueous as well as hydrogen ions. Okay, so that's under basic conditions. Okay, that's basic. And this one here is your acidic. If I can spell. Okay, so I'll just wipe off this working out so that way we can show the basic and acidic together and see the difference.